Today we're going to see about the topic of comparison of LIDR and radar. I am Kevin from Artificial Intelligence and Data Science. Introduction. Lidar and radar are both remote sensing devices that are often used for detection, tracking and imaging of various. While they are used across a broad range of industries, lidar and radar are setting up a bus for their functionality in the autonomous vehicle space. The discussion around which one is better has plagued in the industry for a while. Most manufacturers choose lidar sensors as their top sensing device. On the other hand, Elon Musk, CEO and a central figure in the industry, have shown in preference for radar on multiple occasions. Self-driving vehicles need to aware of their surrounding environment. Often the system that enables object detection in the autonomous vehicle includes a variety of sensing devices connected through a sensor fusion algorithm, including lidar and radar, ultrasonic sensors and cameras. While they have overlapping goals, the simple change of the type and wave used makes their capabilities vastly different from one another. What is lidar? Lidar stands for light detection and ranging, or laser imaging detection and ranging. While it's fairly new concept compared to radar, it's been around since the discovery of laser in 1960s. There are two types of lidar sensing devices: airborne and ground based. Ground based lidar uses laser with a wavelength of 500 to 600 nm and is used in various applications such as landslide studies of or obstacle detection in automobiles vehicles. Airborne based lidar, on the other hand, uses laser with a wavelength of 1000 to 1600 nm and mostly used to collect training data. Lidar system or depends because they are capable of measuring an environmental with high accuracy and producing a 3D image based on the result. How does lidar works? The laser used to detect object in lidar either be distant or continuous. In measurement, full waveform signals are often used in forestry, while pulsed signals have more use in other fields. Lidar system mainly consists of light source and a receiver of sensor. The source beams out light and laser which bounce off the target and back towards the lidar system, where the sensor catches the pulse. On its own, lidar can catch the position, size and shape of an object relative to the lidar system. However, lidar sensor are often paired with a GPS and IMU sensor or a camera to enhance their capabilities. What is radar? Radar stands for the radio detection and training. Just as its name suggests, radar working principle is almost identical to lidar, except it uses radio waves instead of laser or light. Radio waves have a much longer wavelength compared to light waves, making radars able to cover longer distance compared to lidar device. The frequency and the type of radio waves used depend on the requirement of use measurement device. The discovery of radar preceded lidar, with the first known applications of radar data dating back to the early 1900s. Radar systems are mainly used for tracking, detection and 2D imaging in various industries such as environmental studies, military defenses and the development of smart buildings. How does radar works? Similar to lidar, radars have two main components: a transmitter and a receiver. Here the schematic of a modern radar system. Here some diagram to clearly explain you. The radio waves used by radar system can also be continuous or pulsed, which are the most frequent option. The transmitter and the antenna in radar work together. The transmitter generates an electromagnetic wave and the antenna sends out the wave through a medium. Then the signal travels through the medium and is reflected by the target back to the radar system, which accepts the reflected radio waves through a receiver. The radar processes the radio waves and determines the distance relative to the system by using the time interval between the transmission of the signal and the time when the reflected signal is received. The radar system uses an antenna to transmit radio signal. Depending on the applications of radar, the frequency of a signal transmitted will carry. The frequency of your radar decides the limitations and capabilities of your radar system, such as range, wavelength and antenna size. Systems with higher frequency have lower power, higher attention and more granular detection, which makes them perfect for short range applications that need a higher resolution, such as autonomous vehicles. Radar versus radar, which technology is better? While radar and radar have identical goals and principles, the type of waves used by both systems created a whole new level of difference between them. Rather than which one is better, radar and radar system have their own place in your system with their advantages and disadvantages. As you can see from the image above, images formed through a radar system are crisper and much more detailed than one formed through radar. Radars used light signals that work in the nanometer range, making radar system much more accurate and precise than radar system. A lower wavelength also means that the radar system can detect smaller object the size of target and created 3D images of the. On the other hand, the resolution of radar images is limited by the size of an antenna used. Antenna with bigger size with keep in mind that equipment for the antenna also depend on the limitations of your measurement system. In short, radar is your best choice when you need a accurate detailed image, while radar is the better when constantly detecting the distance to the target is more important for the case. Everybody, Reliability. Which radar accuracy leaves much to be desired. It's much more reliable than radar. Radar use light waves as a medium and is easily affected by the medium itself. For example, moisture in the atmosphere affect the performance of a radar system. Radar system do to perform as well in bad weathers such as rain, fog, and snowstorm. Radar, on the other hand, uses radio waves that have a much bigger wavelength, so it has enough power to cover longer distance than radar. Radio waves are also lower attention, which allows them to travel manually distributed even in poor weather. When sensors that rely on the principle of optics are compared, radar is the excellent choice as a substitute even with its low resolution. Cost. For many years, radar sensors are not an option for the manufacturer thanks to its high cost. A high and automatic radar by Velodyne used to cost $75,000 for one car. However, in recent years, Lidar have been undergoing a significant price reduction with many companies working to make Lidar system more affordable. In early 2020, Valorant released a solid state Lidar with no moving parts for called visibility on the zero. The prices of Lidar sensor is partially responsible for the high prices of autonomous vehicles. Most include the use of Lidar to detect the environmental for their self-driving functionality such as Waymo, Toyota and Uber, while Tesla continues to avoid Lidar and develop radar for its self-driving cars. Conclusion. Except for the types of wave used, Lidar and are almost identical in principle. Both use a transmitter to emit a wave and use reflected wave received by the sensor to decide the precise distance to the target. Thanking you.